This conference will now be recorded.
Okay, up to this we completed. So what is field, column, row, record, table, database, instance, data? Very basic things only. Yesterday we completed, which are some basic terminologies related to database. Now, in this database, one concept is there, normalization. This is one important thing. In many interview, you will get this question: what is normalization? Or they can ask like difference between normalization and denormalization. So this part developer people will involve, not tester. But for question for developer, tester, support, everybody, this is one of the interview question. So before going and understand about this technical thing, first try to understand the normalization meaning in generic meaning. What is the normal meaning of this normalization and denormalization? So whenever normalization word is coming, the meaning is standardization. Suppose you join in one company from last 10 years and they have not given good hike. Right now market is good and 4-year, 5-year experienced candidates are getting around approximately or on an average 10 lakhs suppose. So you already joined from last 7 years in one company and your package is 4 lakhs. So that is not in standard form. So in that case, many employees can leave the organization. So what company will do? Company people mostly they are leaving means that is also not good indication for the company. So they can make it standardization. So current market standard, whatever it is there, maybe immediately 200, 300% hike they cannot give, but 60, 70% or something they can give hike. So employees is benefit and company organization side also benefit, and both are happy to each other, both side, and they can continue. So that is standardization. So in technical meaning, we can tell it as a normalization. So another example we can take engineering semester BTech suppose. So now how many semester is there? 8 semester. Now again few universities is split into trimester and 16 it happened. If we go back to few years, 20 years around or 25 years, this was 4 years, 4 exam. Before that, two year, one exam was there, two exam. Before that, one only final exam in all 4 years. So one exam is there in all 4 years. It is very difficult. We are not a computer that we can remember everything up to 4 years. And in 4th year, last exam, if you are giving all 4 year, all papers and everything need to revise. So it is not easy things to recall everything from last 4 years. Our brain, we can remember up to 3 months, 6 months, 8 months or 1 year, that is fine. But for 2 year, 4 years, 6 years, that is very difficult. So a lot of problem happened. That's why they split to two exam, 2 years, one exam, another 2 years, one exam. Again, a lot of difficulty came. So it's splitted into 4. 1 year, one exam. Again, some difficulty happened. So they split into again two parts. So 8 exam. Now some are already decided 16 parts also. So if small part is there, it will be very easy. For understanding it is easy, for students also it is easy, for management also it is easy, for teachers, instructor also it is easy, for exam related, job related, backlog, everything it will be good way. That's why it is splitting. So now it is in standardized form. So what we can tell it as a normalization. So anything is present, any kind of information is present in one place at a time only we can see. So that is giving a lot of confusion, confliction, and lot of difficulty hurdles we are facing. For that, it can be split into some small part. And those parts will be designed or prepared such a way that it will be very convenient for everybody, easy to learn, easy to work, easy to use from management side, from user side, from client side, for everybody. So that it will split into small part, and those parts will be split as a normalized way, standardized way. So everything will be independent and we can work all those things one by one. That is the normalization. So everything is present in one place, that is called as denormalization. Denormalization. One exam only we can give all whole semester or all 4 years paper we can give in single exam one time. That is denormalization. So if small are there, 2 exams, that is also denormalization. So many parts we split it, that is normalization. So normalization means it is splitting into multiple parts. split into multiple parts. And denormalization means combined into small, means a single part or two parts. So here suppose it is splitted with 20 parts or 10 parts. So those 10 can be kept into one place or two place. That is called as denormalization. So that is normalization and denormalization. Now we can come to this technical side, what exactly this is. So normalization is the process of minimizing the redundancy from a relation or set of relations. So this first definition only good one, you can refer this. So technical word you can use as redundancy. So the meaning of redundancy is so many on what we can say invalid kind of informations are present, then junk informations are there, then unreadable data are there. A B C D X Y Z 1 2 3 4 we are able to read. Some symbols are there continuously, those are unreadable format. So many nulls are there, no data but unnecessary empty 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 it is present. So many duplicate informations are there. So in those cases need to reduce all those kind of unwanted things. So all these are unwanted things we can say, or unwanted data we can say. So those unwanted things in a technical word is called as redundancy. So we can reduce the redundancy or minimize the redundancy from set of data or set of relations or set of tables. So what process is using for that, that is called as normalization. So coming to the real-time project, so many informations will be there. Suppose one hospital related information is there. So in that, many places branches are there, many doctors are there, then many insurance third party company are coming, many vendors are connecting with them, and so many patients are admitting from different places, they are coming with different transport facility, lot of things are there. So everything will be present in one place, one table, one file. Lot of difficulty it will be faced. So they can split into multiple parts and in separate table it will be kept so that it will be easy. Patient informations one table, only doctor informations one table, then hospital related address informations one table, then all the disease related, what disease can be take care with which approach and what surgery, for that one table. Now it will be easy to understand for working purpose, for maintaining purpose, from management side, billing side, transaction side, then traveling, for everything it will be easier. That's why they can split into small parts and they can maintain the information in different tables. So the process which is using for that, that is called as normalization. So normalization is a process of minimizing the redundancy. So this kind of redundancy means unwanted things. It can be duplicate, it can be junk data, it can be invalid data, it can be repeated data, it can be unreadable format of data. Everything will mean to one word only, redundancy. So no need to explain all those things. One word is enough. So this technical word only need to use in many books, articles, this one only given. So minimize the redundancy from set of data. What process is using, that is called as normalization. Okay, so here different definitions with different approach it is given. So no need to discuss, you can go through later. Again, it will be confused. So first definition is the good one. You can refer that. Okay, so eliminate the redundant or useless data, which is unwanted or useless. Those data will be eliminate, reduce, minimize, remove, delete. Then all the valuable data, useful data only keep together separately. Ensuring data dependency makes sense. So those should be dependent. Patient information should be dependent with doctors. Doctors should be dependent with hospital address. So all will be having some relationship. Next is denormalization. So denormalization is a database optimization technique in which we add redundant data. So here in normalization, removing or eliminating or reducing the redundant. Here in denormalization, adding the redundant, making the redundant, opposite one. So here we are adding the redundant data to one or more tables, because lot of informations we are keeping into one place means it will come as combo data and it will be redundant only. Automatically it will form that redundant. So out of all those, many will be irrelevant. So many junk will come. So after combining, maybe some will be unreadable, maybe some typo mistake can happen. So a lot of things are there. So if you are clubbing many things in one place, then difficulty will start. So that is the redundant data. So non-redundant data is normalization, redundant data is denormalization. Simple one. This can help us to avoid the complex join. So in which case it will be helpful, this denormalization, whenever any complex join is coming, in that case it is helpful, because here one table is there, then no need of join, or two table is there, then only simple join we can do. If so many tables are there, in normalization 10, 20, 30, 40 tables are there. So need to understand which table will be combined with which table and what kind of join concept need to use. So 10, 20 we are joining, mean the query will be complex. So here with respect to join related concept, it will be simple. But other things if you will see, then normalize is the good approach. And in real time, always they are using normalized data only, not denormalized. But finally, if it is placing somewhere, then that will be denormalized. Like gathering the means some products and anything, and that you can keep in a godown. So that godown we can tell it as a denormalized. Separately we are collecting wheat product, rice product, and some different products. So separately we are collecting. Those are normalized way we are collecting, and finally we are placing into one warehouse or in a godown. So that is the denormalized. So single place or there is less place we are keeping, that is denormalization. So here data also we can keep in that way. These are few difference between normalization and denormalization. First one is definition, implementation, definition. So normalization is a process used to remove redundant data from the database and store non-redundant data and consistent data into it. That is normalization. And what is denormalization? Denormalization is a process used to combine multiple table data into one place or two place or very less place, so that it can be quickly identified in one place only. No need to search from multiple places. So some cases denormalize will be helpful. In some cases normalization will be helpful. Next point is focus. So normalization mainly focus on clearing the database from unused data and to reduce the data redundancy and inconsistency. So here the main focus is, main objective is how the redundancy will be reduced, inconsistency will be reduced, unused data we can reduce. That is the main intention here. In denormalization, the main intention is in one place we can keep everything, so no need to search in 10 places. Keep one place, we can get everything from that one place. So who are looking for that? In that case, denormalization is useful. Then come to number of tables. Number of tables will be more in normalization, because one table is split into 2 parts, 3 parts, 10 parts, 20 parts. So here splitting mechanism is coming. That's why table count is more. In denormalization, table count is less. It will decrease the number of tables. Maybe one table or two table or three table will be there. But in normalization, 10, 20, 100, 200 tables will be there. So count of table will be more in normalization. Count of table will be less in denormalization. Then memory consumption. Normalization use optimized memory and hence faster in performance, because here some process is using and it is splitting in very good way, standardized way, and optimizing the memory also using some performance tuning concept, so that the query of this normalized table are very fast. And in denormalization, we are gathering everything in one place, so optimization technique cannot be used, performance tuning will be not appropriate, so it is very slower. As compared to normalization, it is very slower. So many wastage of memory here. Next come to data. Data per table in normalization is decreased. So one table if you will see, so one table is split into 10 parts. So obviously single table splitted one, if you will check, then memory will be less only, data will be less only. In denormalization, everything is present in one place, so obviously data will be more. So data size if you are seeing in one table only, then denormalization will take more. In one table only we are seeing the data in normalized mode, then that will take the less data only, because whole data is split into 10 table, 20 table, 30 tables, so obviously it will be less. Next is data integrity. So integrity, we'll see later, different chapter is there, practically we'll see all those things. So for the timing you can just understand that integrity means relationship. So the table will be split such a way that one table can be linked with another table. 10 tables are there. So A table can link with B table, B can combine with C table, C can link or combine with D table, like that. So some relationship will be there. What is that relationship? Some common column. Suppose customer ID is there in one column, student ID is there as a column in one table. The same column name is present in another table also. Then we can tell that as a common column. If common column is there, then we can combine those two tables using join concept. If common column is not there, we cannot combine. Like two flats are there, two houses are there side by side. If common wall is there between that, then we can combine that two flats into one big flat. If common wall is not there, we cannot combine that. No other clue, no other solution, nothing. That's why in normalized tables, which are splitted, which are forming, designing, creating, preparing, always developer people are maintaining some common column as a relationship. So that relationship is called as data integrity. So in that chapter we'll discuss more. Now just you can understand that some common relationship is required here. So this data integrity is used or available in this normalization, but the data integrity is not used or maintained or available in denormalization, because in denormalization one or two table is there. So what is required for the relationship? Here 10 tables are there, 20 tables are there, so relationship is required so that we can combine. Where to use? So if more operations are going on, insert, update, delete, modification, then remove, then adding the data, all those are very frequently it is happening. In that case, normalization is required. Wherever these kind of operations, inserting, updating and deleting are very rare, then in those cases it is not required. Denormalization is fine. So here two things are there. One is database and another is data warehouse. So we started with database. After few classes, we'll start data warehouse also. So data warehouse is derived from database only, which can take or keep up to some terabyte of data. This is also a database. This is also a database. So this database will keep up to some gigabyte of data. So we can tell it as a database. So only current informations. So we are using bank account. So current transactions we can get up to 1 year, 2 year, 3 year. Suppose you are using that bank account from last 20 years. If you want to see the last 20 years all transaction, you cannot get that. We need to go to bank, give one application for getting those transactions, mention some reason, I want to take some home loan or something, 50 lakhs or something, then we can get the 20 years transaction or 30 years or 20, 15 year or 10 years also. So what is that? They are extracting all those history. So history will be kept in data warehouse. Current informations will be there in database. So we are using our account login and seeing all the details, that is database. So if more details we need as a history also, 20 years, 30 years, 40 years, we cannot get that. We don't have that option. So we can go to bank and ask them. So they are using data warehouse, they can give complete history. So day by day, whatever data are maintaining, that is called as operational data, or that is also called as current data. So today we went to one ATM, withdraw some amount. Tomorrow again we can go. Yesterday already withdraw. So these are currently happening. So 2 years before also we did something. 10 years before we did something. This kind of transactions. Those are history. So today's data only, it will be old slowly and it will become a history. So history means 5 years, 10 years, 20 years old. That is history. So if history plus current both we are maintaining, then more memory required. So in database that is not sufficient. So in the same kind of database only, it will be assigned with more memory, which will take up to some terabyte, and we can maintain current plus history both information, then that is called as data warehouse. So more details we'll learn in this data warehouse topic. Now in shortcut, you can just remember data warehouse is deriving from database only, which can maintain current plus history both kind of information, so that more memory it is required. And in database some limitation is there up to gigabyte, so that will not support up to terabyte. If history we are maintaining, then it is going up to some terabyte. That's why on top of the database only more memory will be assigned, which will be called as data warehouse. So whenever we are gathering the data from multiple database, one database, another database, and keeping into final place, then we can tell it as a data warehouse. Those are the historical data with very big picture. So this database, another name is OLTP, online transaction process. So whatever current transactions are happening, all those are online transactions, we can say. So current transactions, online transaction process are called as database. And data warehouse, another name is OLAP, online analytical process. So this data warehouse or OLAP use denormalization, because all data will gather and finally it will place in one table or one database or one data warehouse. So that is denormalized form. And database, so many tables will be there, small part. We can use all those in normalized way. So that is database or OLTP. So OLTP or database is normalized or normalization. Data warehouse is denormalization. So database, then we can go for data warehouse also, already told in starting session. Then we can use ETL concepts, then reports will be generated, that is called as BI reports. So slowly we'll go one by one. Now we started with database, then we can move to data warehouse also. So in interview you can get this question, database is normalized or denormalized. So database is normalized. Data warehouse is normalized or denormalized. Data warehouse is denormalized. That point only mentioned here. Okay, next one is CRUD operation. So what is CRUD? This is also one of the interview question, and in many of your project documents it will be mentioned. So at that time no need to ask anybody what is CRUD CRUD, or in meeting some discussion is going on, somebody is telling about CRUD or CRUD operation you completed or not. At that time we should not ask what is CRUD. So these are very basic terminologies only. So the full form of CRUD is CREAT, create, C for create, R for read, U for update, D for delete. So if you will work in any company, organization, any project, these four kind of operation, create, read, update, delete, very frequently need to use. Daily 20 times, 30 times, 40 times we have to do. So if we are telling to somebody in a meeting or documentation or something we are preparing or telling, then create, read, update, delete, create, read, update, delete. If you are telling, that is not looking good, lengthy one. So to use this as a shortcut, direct we can mention, we can tell that C for create, R for read, U for update, and D for delete. Direct we can tell or mention in document CRUD, CRUD, so that everybody can understand, no need to explain to anybody. In most of the application, we have some kind of CRUD functionality. So any kind of project application we can work, it is expected that we can be engaged, involved into this CRUD operation regularly. CRUD application is one that use forms to get data into and out of a database. Using this CRUD operation, we can enter, and we can make out also. We can take the data and we can fetch the data, we can out, means we can make it out also. So in out it will happen. Creating, so we are making in, entering the data. Read, we are fetching, seeing. Again we are changing something by update. Again we are removing also. So total in out will happen using this CRUD. Okay, next is data dictionary. So this is also one of the terminology, very frequently it will be used in most of the projects. So common word dictionary means, everybody knows some books are there, dictionary books. So if maybe you are having that books also, we are using this kind of dictionary books for understanding some words whenever we are translating. from one language to other language, English to Hindi, Hindi to Marathi, or Marathi to Telugu, or some other language. So many dictionaries are available. So what is the use of that dictionary? As a shortcut way, in summary informations, it is explained in very good manner by giving some diagram or giving some explanation, example, so that we can understand the meaning of that with translation from one language to other language. Similarly, in database also one dictionary they have provided. So if you are having some doubt or we want to see some more information about something, then no need to ask anybody. Directly we can go to the dictionary and we can see the information. So we can try to understand that. So what kind of informations it gather? It gives metadata information. So metadata information means some summary or short informations about the data. So what kind of database it is, which schema are available, what are the different tables, how many tables are there in the database, then what memory it is occupying, what kind of columns are available, then which kind of data are there, index is used or not. So these kind of metadata information, structure kind of informations are present in the dictionary, and that dictionary is purely related to data, no other kind of thing. One language to other language, not like that, or any product to another product, not like that, purely data related. Within the database only, whatever data are present in different object wise, table wise, column wise, index wise, performance wise, all those related some summary informations are there. As a structure, as a design, we want to see that in more way. So in that case, we can take the help of dictionary. So here books are not there, they have not provided any books. So they have given those information inside some tables. So database means everything will be in tabular form only. So those tables which are maintaining as dictionary purpose using the data, the name they have given as data dictionary. So the another alternative name of this data dictionary is data definition matrix. So in interview they are asking this question also, what is data dictionary? What is data definition matrix? Or some are telling it as a system table. System is already given these tables. So any of the name we can use, system tables or data definition matrix, DDM, or data dictionary, DD, anything is fine. So it is having some set of information which will describe about the contents of database, tables, formats, structure, and relationship between those tables and their elements. So those informations are, it is described in this data dictionary, means some tables are there in that it is mentioned. So this is the collections of tables with metadata. Metadata, data about data is called as metadata. More information about data is called as metadata. So it gather the information about the metadata. So this is just a centralized repository. So this is centralized repository. All kind of schema, tables, and everything will be placed here with some summary information, which is centralized. So another name of this data dictionary is data definition matrix, which provides detailed information about business data, some standard definition, what kind of elements are present, what are their meanings, and which is allowed, which is not allowed, and many more. So later on we'll see some data dictionary tables also. In table level, some data dictionary tables are there. In view level, some are there. In object level, in index level, in constant level. So in different topics, whenever we will do, we will see all those related data dictionary tables. Which kind of information are present, we can see that. So there are so many data dictionary tables, 100 plus data dictionary tables are there. It can go 500, 1000. So all are not required for us. Those are purely required for database administrator. But around 10 to 12 tables are there, data dictionary table, that is required for developer, tester, and support people. So which are required, all those we will see practically. Okay, so we'll focus on this Oracle database. In Oracle also few data dictionary tables are there. Few of them it is listed here. These are the names. One is tab. So all the table details it is present in this tab data dictionary. All underscore users. So many users are having one login credential. By using that only we can enter into database. So who are those users, their login details, schema and all those things, it will be mentioned in this all underscore users table. All table only information, all underscore tables. All objects related here, constraints related, table as well as columns, here it is present, views, index. So specifically it is designed and maintained so that all those specific informations will be present in those corresponding data dictionary tables. So what is data dictionary table? And tell few names which you already worked or which you already know. This is also one of the interview question. So try to remember 3-4 names from all these. So same kind of names are present in other database also. Okay, next is acid properties. This is also one of the interview question. What is acid? Can you explain? Okay, so just 1 to 2 class only, it will be theory. After that, we'll start practical only. So once practical will start, you will feel more interesting only. But these are required. If not interesting, whatever it may be, these are required for interview as well as if you are working in any project, any meetings, discussion is going on, you should know all this terminology. At that time, we should not ask to anybody. Okay, next is acid properties. So here acid also having some full form. A for atomicity, D next is C for consistency, and I for isolation, D for durability. So these 4 key properties are having by a database: atomicity, consistency, isolation, durability. So need to remember the full form of these 4 words, and then just 1 line or 2 line of explanation of each: atomicity, consistency, isolation and durability. That is enough for this question. So what is this atomicity then? So this acid is the acronym of set of 4 key properties which are atomicity, consistency, isolation and durability, which will define the transaction in database. So any transaction we are doing in database, these are 4 properties available. Already it is defined so that it is maintaining in very good way from starting to till date. So these are the 4 properties or characteristics already defined or designed in the database level. First one is atomicity. So what is this atomicity? Atomicity means that we can guarantee either all of the transactions succeed or none of it does. So here, if we are executing a query, that query is nothing but transaction. So if we are writing a query and executing, that query is having some lines of code, suppose script. So first line, second line, third line, fourth line, fifth line, sixth line, like that. So we have written one query with 6 lines of script or 6 lines of query we have. This is one structured query language or one SQL query we have written. Now we are going to execute this. How to execute, we'll see. So we are going to execute, suppose. So if executing, everything will be executed all together and finally it will display one output here. Suppose out of all these lines, somewhere problem is there. Here some problem is there. One syntax problem or some approach is wrong or something issue is there. Now it will not give any result. So if it is giving result, then 100% it will give result. If it is not giving, then it will not give any result. 0%, either 0 or 100. In between it will be not there. 30% result it will give, 20% result it will give, 40% result it will give. Which line is correct, that output it will come. Which line is not correct, that output it will not come. It is not like that. In shell script or any other scripting language, that feature is available. Suppose this is a scripting language, shell script, JavaScript or some other script. So what it is happening? Out of 6 lines, 3 lines is correct, 3 lines is not correct. So for those 3 correct lines, it will display output, and 3 incorrect lines, it will display error. That is happening in scripting language. But in this query language, database side, if executing, everything will execute and display the result 100%. If any small mistake is there, totally it will not execute. 0. We cannot expect any result. So that is one feature which is called as atomicity. So atomicity means it will guarantee that whatever transactions it is going for succeed or execution, it will go whole way, or it will go nothing. None of it does. It will succeed means everything will be done or nothing will be done. Either or. Either everything or nothing. Not in middle. It will not stay in middle. That is one properties. So the name they have given as atomicity. The meaning of atomicity is this: yes or no, not in middle. Next is consistency. This is another properties of database. This ensures that all data will be valid and consistent according to all defined rules before that and after transactions. Okay, so consistent data should be there. The data should be consistent. Whatever data we are using, this database is ensuring that, confirming that, guarantee that whatever data we are using, all those are valid data and consistent data. Few rules are there. So to implement those rules, some concepts are there: constraint, cascade, trigger, and some other. So we can see all those constraint and other things. So using all those concepts, data will be filtered in very good way. Valid information it will come, junk information, duplicate information, invalid information, inconsistent informations will not come. That is one very good rule of this database, or very good properties of the database. So always it will try to maintain the consistent data, valid data, very good information data only. Unwanted things it will not keep, junk data it will not keep, duplicate data it will not keep. So these kind of things it will be ignored, and all the valid information, consistent informations only it will keep. For that, some rules, some process, some concept are already available. So this is called as consistency. This is also one of the good properties of database. Next is isolation. Okay, so what is isolation? This is another properties of database. It will guarantee that all transactions will occur in isolation. No transaction will be affected by any other transaction. So any query we are writing and executing, suppose we have written 5 query. In a team you are working, 10 persons are there. A is 1 person, B is 1 person, C is 1 person, D is 1 person, E is 1 person. Suppose 5 different persons are working in a team. So A person written some queries, 3 queries or 4 queries. B persons writing, executing and working with 3 queries, 8 queries. D persons is working with 7 queries. E person is working with 6 queries, like that. So all they are working independently, no disturbance to any other. So these queries are designed such a way that in the database, anybody is writing the queries and executing, it will not disturb or not impact to any other person. If A is working, it will not disturb to B. If B is working and executing, it will not disturb to C. In that way, it is designed so that independently everybody can work. Any number of team members are there, everybody easily they can work, no disturb to any other. In that way only it is maintained. That is called as isolation. Otherwise, A is working, B is disturbing. B is working, C is getting some problem. C is working something, E is getting some problem. So how they can work? So these are independently designed. So any query we can form and execute, no disturbance to any other person. In that session he can open, and that will be locked for him, and independently he will get that result, and that will not go and implement in any other session who is open. So it is ensuring or guarantee that all transactions will occur in isolations, means independently, and it will not affect to any other persons who are working in any other transaction. That is called as isolation. So this is also one very good property. And another is durability. Durability means once a transaction is completed, means committed, it will remain in the system. So if we have done one task, one transaction, one query execution, so that is completed, it will remain in the system. Suppose some problem happened, it crashed, system crashed suddenly due to some problem, due to some reason, then it will not vanish immediately, because company are using years of data, 20 years, 30 years, 50 years of data. Within fraction of seconds, some network failure happened or some fluctuation happened and all data crashed. So how to recover? That is very big problem. That's why it is designed such a way that in immediate basis it will not remove all data, or it will not go out all data. Even if system is crashed immediately or suddenly due to some reason, it will keep somewhere and it can be recovered. That is also one good feature, because data is very important. So once data is gone means everything is gone. So it is not given any means easier way that anybody is doing some mistake means that data is gone. So recover process is already there and easily it will be not gone. If any problem happened, some crashes of the system or database or application also, it can be recovered. In that way this is designed. So these are the 4 properties and very good properties of database. So what are the properties of database, or what is ACID? Can you explain? This is one of the interview question. So 4 words you can tell with 1 liner, 2 liner definition and explanation, that is fine. Okay, next is DBMS. So all the terminology is completed. Now we can go with the DBMS. So for our understanding purpose, a simpler word we are using database, but the actual word is DBMS, that is Database Management System. Simply we are telling database, and database is a container. So the actual word is Database Management System. So what is that? DBMS is not a file system. They are the application software. So which we are using this database management system, all these are application, and that application is nothing but the software only. So this is not a file like Notepad or Excel or PowerPoint or Word or anything. This is not a file. This is one kind of application only, like CRM application or ERP application, like that. This is also one kind of application, and that application will be used with some software only. This is nothing but the database management system. Database management system, DBMS, is system software which helps the users, programmers, testers in a systematic way to create data, store data, manage the data, retrieve the data, work with all kind of data related activity or operation. That is DBMS. So after that, RDBMS came. So initially, whenever database concepts developed before 40 to 50 years, at that time, first name they have given as DBMS. This is also one of the interview question. What are the difference between DBMS, RDBMS, ODBMS, and ORDBMS? So first of all, DBMS happened. So DBMS, in short form, we can tell database only. So multiple tables will be there. Suppose in a project, hospital related work is going on. Okay. So in that hospital related project, multiple tables are there. One is patient table, and another is doctor table, another is address table, another is medicine table, like that. So here in patient table, patient name, patient ID, then patient mobile number, and these kind of columns. In doctor, doctor ID, doctor mobile number, doctor name. In address, city name, state name, country name, pin code, area name, like that. And here, this is another table. Like that, multiple tables are present. Now, if we want to connect these tables, something should be there as a common. So here, patient ID is there, patient name is there, patient mobile number is there. No any common column we are getting here. So how we can combine doctor ID, doctor name, and this? So this is separate, this is separate. We cannot combine, we cannot connect. So one patient is admitted in this hospital. In which address? No idea. Which doctor is giving treatment? No idea. So what is the use of this then? This is database. Multiple tables are there. So if one table we are using, we are not able to connect with other table. Partial informations we are getting. Patient name is Rajesh. So Rajesh is coming under which doctor treatment? Here nothing is there. If something is present about Rajesh name here, then we can correlate which corresponding doctor. So in this DBMS, that relation was not there. Common relation was not there. So lot of problems started. That's why within few years only they have implemented this relation. So all these table within one schema, suppose this is hospital schema. Under hospital schema, these are the 4 tables. So these 4 tables will be kept such a way that some common column should be present in all these tables. So here one patient ID is there. Patient name can be same. Rajesh suppose. So 10 Rajesh are there. All are patient. Rajesh Burma. Maybe Rajesh Burma 5 persons are there. Rajesh Kumar Burma. Maybe same name Rajesh Kumar Burma also 3 persons are there. Again it will conflict. So who are admitting in the hospital, they will generate one patient ID. So ID everywhere it is there. If you are opening one account, customer ID. If you are joining in any company, employee ID. So everywhere we can go, some ID are there. As a customer, customer ID. So here also, as a patient, they will admitted in the hospital, then patient ID, one column they can maintain here. And that same patient ID they can mention in this doctor also. One patient ID column. Now patient ID is 1, 2, 3. Then we can check here. Here also 1, 2, 3 patient ID. So this patient name is Rajesh. This patient mail ID is this. Mobile number is this. Now we can come to this table. Okay, come to this 1, 2, 3. Okay. So this person 1, 2, 3 patient ID Rajesh is coming under treatment with one doctor, some doctor name. We can get that. Similarly, in which address he is admitted, many branches are there for that hospital. So here, doctor ID or branch ID something will be there in this table. So that branch ID will be available here also. Now we can connect this. We can get in which branch. Similarly, another table. So many tables will be there, and few tables will be connect with some common column. So that all column from here to here, here to here, here to here, we can connect. So this is called as a relation. Previously relation was not there. So the name they have given as DBMS, Database Management System. Later on they added this relation, some common relationship between the tables within one schema. That's why they have changed the name as RDBMS, Relational Database Management System. These are the common relations. Next, again few are in research for this database whenever newly it started before 40 to 50 years. So at that time, first 5 years or 10 years only, it was going on as a research only. It developed in USA in one research center only. So at that time, again, the research was going on. So one research happened, RDBMS, they added. Again, those research people come up with some conclusion. Oh, object oriented. So what is that? So here, as a table wise, keeping the data, this is one table, this is one table, this is one table, this is one table. What is object? Object in database means it can keep the data, store the data physically or logically, or it will refer the data. So it will store logically or physically, or it can refer virtually. So which are containing those kind of things, those are called as object. So table is keeping physically data, table is one object. So up to DBMS and RDBMS, only one object was there, table. So slowly, these database related works are going on in many projects, many companies. So a lot of disturbances, lot of problems, lot of complaints came. What are those? If suppose same table is using by multiple persons again and again, somebody is updating, somebody is deleting, somebody is inserting. So same table, so it is disturbing to them. Problem started. So individually they are not able to work. Same table if they are using. So if only fetching the data, fine. If inserting, then somebody is inserting for his requirement. Another person is deleting for his requirement. So it started problem in that case. So what to do? For that, another object they introduced that is called as synonym. This is another object. So we can create one kind of replica of that table. So 100 persons are working with this one single table. So 100 replica they can create and individually they can work so that it will not create any problem. So this is one good feature there. Without disturbing to anybody, everybody can work. Now, this synonym is taking space again. This single table is suppose having 5 gigabyte of data. 100 persons are created, then 500 gigabyte. and memory is increasing, then company need to purchase that. It is not free. So whenever price concept is coming, everybody is concerned about that. So why unnecessary company will purchase? Again, complaint. They did some complaint. So what to do? Without taking any memory, how we can use? Because this is temporary. Those 100 persons are using the same table. After that, this table is only one finally. So why 100 times they will create and it will consume the memory and will purchase that by giving some price. That's why another concept, another approach they added, that is called as view, another object. So using view also, the replica will be taken virtually. It will not consume any memory, zero memory. Thousands of tables we can create, not a single memory it will occupy. Very good feature. This is added. After that, index is added, another object. So what is this index? If we are writing some query and executing, we are getting the data, but it is taking 1 hour, 2 hour, 3 hour. Who can wait and sit? Nobody is having time to wait all those things. So that was one problem. So using index, that can be very faster, which is completing in 2 hours, that can be complete in 2 seconds. That is index, very good approach. Similarly, sequence, another object they added. So wherever any table is created and 1 lakh customer informations need to keep in that. So everybody will have one customer ID, suppose. Any bank or telecom or any example you can take. Customer ID is applicable everywhere. So if customer ID maintaining in one column, suppose this is customer ID, then somebody is having one customer ID, then 2, 3, 4, 5 like that. So what is this? This is sequence number. So if 1 lakh customer or 1 crore customers are there, need to add all those one by one. 1, 2, 3, 4, 5, 6. If we are adding one by one, one by one, one by one for all these 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 up to 1 crore, lot of time it will take. So they come up with some conclusion that if any sequence number is required, roll number, student ID, customer ID, account number or anything, one sequence object they added, so that starting value, ending value, 1 crore or something. And what is the incremented value? Increment by 1. Just mention that within fraction of second, it will keep all this 1 to 1 crore. Very good one, this is also. And again, another is table space. So table space means memory related. If one table is assigned with 5 terabyte, so that is not keeping those much data. So unnecessary that memory is waste. So they come up with some conclusion that if required, increase that memory, not required, decrease the memory. Previously, increase decrease option was not there. Just assign that, that's all, which was wasting the memory. So these are the 5 new objects they have added: synonym, view, index, sequence, table space. Only table object was there earlier, up to relational database management system. So later on, they added these 5 more objects. So 1 plus these 5, total 6 objects. How many objects are there? When you want to interview question. So we'll see later practically all objects which are required. So these 6 objects they have added, and the name they have given as Object Oriented Database Management System, OO. After that, it observed with many experts and who are in the research activity. So they discussed with their own opinion and they finalized, they combined, they observed and they discussed that relation also very good feature and object also very good feature. We can combine these two now. So they combined that, and that name they have given as Object Relational Database Management System. Object is there, relation is there in database management system. So nowadays, now in today's date, whatever we learn, we'll see all the database, all are object relational database management system only, which is the final one. From that time till today, everybody is using that. So we can use Oracle or DB2, MariaDB, Postgres, any kind of database we can use. All are having relationship, relational things are there, and objects also added here. Since this is a lengthy name, so some are telling DBMS, some are telling RDBMS, some are telling ODBMS, some are telling ORDBMS. If you are seeing some books or articles in online, some portals also, in different places, different name is there. So from today onwards, don't confuse. Final one is ORDBMS only. Everywhere object is there, everywhere relation is there. That is the final one. For telling purpose, find any name we can tell, everybody can understand. Who are into database side, they can understand. But the final one is ORDBMS. Okay, so this is about DBMS, RDBMS, ODBMS, and ORDBMS. Next one is data information. So till now, any questions? Any questions from anybody till now, or all are fine? Anusar, Rohit, Jamir, Manjari, Salini.
Sir, can you please explain me the acid properties consistency?
All good, Prakash.
Okay. Consistency. Database must be consistent before and after the transaction. So some rules are already added in the database level, like some examples given: cascade, triggers, constants, and all those things. So using all these concepts means valid data only it can kept. Unwanted data we can restrict. Suppose age is there. Customer who can open the account, minimum age criteria is 18. Below 18 age, they cannot open the account. So one restriction will be added in that column. Anywhere we are adding the data below 18 age, 16, 15, 13, 12, it will not allow. It will throw some error. So due to that restriction, we are getting the valid information. If that is not added, then maybe somebody can add with 12 age, 13 age. So those are invalid data we can get. So using this, we can restrict also. Similarly, some other kind of restriction also there. Using all those, we can make the valid data or consistent data. That is called as consistency. So this feature is available in the database. We can restrict. If you are traveling by flight 20 kg, beyond that you cannot take. That is one restriction. If that restriction is not there, then so many people are traveling, so they will take with lot of luggage. So problem will start. So to avoid all those difficulty and problem and all those things, some restriction is added. So here also we can restrict the data in proper way. So those kind of facility are provided in database. That is called as consistency.
Okay.
Okay, next is data information. So what kind of data are available? So here already told from starting that you have to work with data only. No application, no web service, no other thing. You have to concentrate on data. Your work start with data. Your work end with data. In middle, everything will be data. Pipeline will be data. Flow will be data. You can play with data. Everything with data. So what kind of data exist in the world and which data we can use? So basically three types of data are available in Word. They are structured data, semi-structured data, and unstructured data. So what kind of data we can tell it as structured data? Structured means it is having some combination of rows and columns. So here in structured data, rows will be there and column also it will be there. Combinedly we can use those. So those kind of data are called as structured data. So what are those? Database, data warehouse, ERP, CRM, all these are having structured data. Even a small example or simple example is Excel also. So out of all those, if one column we are taking, suppose student is one table, maybe Excel sheet or maybe in database any table. Student is one table. So in that student table, student ID is there, student name is there, student mobile number is there, student city name is there. So any column we can see, suppose student name, Rakesh, Rajesh, Soni, Mini, so many names are there. So one column we can take, we can get all the list of student names. Any other column, suppose mobile number, list of mobile numbers of all the students, list of student ID or roll number. So any column we can take, we are getting the list of values, and those values are meaningful values. Now column gone, row we can come. So one row we can see, suppose randomly I am taking this row. In this row, suppose one person is there, Kiran. So his name is Kiran, his student ID is 5, his mobile number is something, mail ID is something, he is from Pune city. Similarly, another row we can take. So complete information of one student we are getting, complete information of another student we are getting. Like that we are getting some information. So row wise if we are taking, we are getting meaning. Column wise if you are taking, we are getting meaning. Both way we are getting the meaningful information. So those kind of data are called as structured data. It consists of rows and columns, and individually, independently, if we are taking rows as well as column, we are getting the meaningful information. Those kind of data are called as structured data. What are those? Any database with tables, data warehouse, ERP, CRM, Excel, all these are structured data. Next is semi-structured data. Semi is mentioned. Semi means partial, 50-50, half-half. So in the semi-structured data, here also we can consider rows and columns. Okay, so row wise we can get the meaning, yes, but column wise there is no meaning. 50% meaning is there, 50% meaning is not there. Partial meaning, partial no meaning. These kind of data are called as semi-structured data. So what are those? Few examples are XML. If you have not worked anywhere, forget about these things. JSON, XML, HTML is there, log file is there, that is called also as logs. So who are working or already seen this kind of file, that is fine. Who have not seen this kind of files or not in any technical, not seen, then fine, no problem. So small example you can consider chart. Chart also one kind of data. We are chatting in a group. We are doing chatting one-to-one with a friend or somebody. So some conversation is going on. So one conversation, suppose you can see here. So you are talking with your friend in WhatsApp chat. Hi friend, how are you? One line. Then he is replying, I am fine, I am attending the session. Then again you are asking, had you take dinner? He is replying, no. Again asking, the same thing, had you take dinner? You are also telling no. So when you will take, can we go outside? Like that some conversation is going on. Now we can see first column of each line. Hi, I, had, no, yes, and some other are there. Any meaning is there? First column only we are taking no. Second column if you are taking friend, am, go, like that, no meaning. Third column, no meaning. But row wise if you are seeing, hi friend, how are you? Yes, meaning is there. I am doing good. Yes, meaning is there. Had you take lunch? No. So every line it is having some meaning. Row wise meaning is there, but column wise meaning is not there. Those kind of data are called as semi-structured data. So what are those? XML, JSON, HTML, DHTML, log file, chart, and all these things. So don't think that we are doing chatting and it is deleting somewhere. WhatsApp, Facebook, all these are social media one company. WhatsApp company, Facebook company. They are also taking all these details data into their servers. Some testing department is there, some development department is there, some companies are handling all those. That is also data. It is not like that is not a data. That is also data. So what kind of data? Semi-structured data. And another third category of data is unstructured data. So what are those? In this unstructured data, if we'll consider again row and columns. In structure, row meaning, column meaning. In semi-structure, row meaning, no column meaning. Now again we can take for this unstructured also row and columns. No row meaning, no column meaning. Row is not available, column is not available. Those kind of data also there. And you have seen, and every day you are doing that also. Maybe today also use those kind of data. So what are those? Video, audio, image, sensor, documents, all those things. So nowadays many clips are going on. We are sending a clip, one video to one group, 300, 1000, 10,000 people are reading this, seeing this. Any column is there in that? Any row is there in that? No. But that is also a data. Audio, many audio things are going on where only sound is there. No image, nothing we can get. That is audio. So any row is there for that? No. Any column is there? No. Image, any logo or any image we can consider. Any row is there? Any column is there? No. But that is also data. Sensor, if you are going to any shopping mall, entry, exit, some sensor is there. It is capturing our all information. How it is capturing? It is taking as a row? No. It is taking as a column? No. We are doing some scanning for our some certification or documents. So that scan document is having any row, column? No. That is like image it is coming. So the data which is not consist with any rows and columns, those kind of data are called as unstructured data. Examples are video, audio, image, sensor, documents. So out of all these three kinds of data, which data we can use in our database and data warehouse which we are learning? First one, structured data. So if you are moving, upgrading your skill into next level, big data Hadoop environment, next level of ETL, at that time semi-structure need to use, structure plus semi-structure. Now that is not required. And unstructured data related, recently only lot of data generations are happening. So it is not up to the mark and many companies not started using that. So we can expect after 1 year or 3 year or 5 year, some new components also it will come into market, and video, audio, image related also we can work on that. Now it is very, very rare, not up to the mark. So many companies have not started working on this. So structure, previously it started from last 50 years. Semi-structure just 10 years back only it started. 2005 it started, but in market it came around 2015. So not 10 years also happened. On structure, now it is in explore research mode. So we can expect down the line within few years. Don't know how many years it will take. So slowly it is coming. So we will use the structured data only. So to use the structured data, structure query language is required. That is called as SQL. So SQL is one language, structure query language, which is deal with this structured data. Semi-structured data deal with no SQL. And unstructured, it is not in good shape till now, so no correct component or tool introduced. We can expect down the line. So that can be in Hadoop, or that can be some new technology, or that can be some with new tools or components. Okay, so these are about data which are exist in the world. Three categories of data are available. Okay, next is relational database and non-relational database. So for structured data, structure query language is using, and for that which database we will use, that is relational database. And for semi-structured data, no SQL language will be used, and which database is used, that is called as non-relational database. These are few list of relational database with SQL and few list of non-relational database with no SQL. So in interview, you will get some question also somewhere. Tell 5 relational database name. Tell 5 non-relational database name. So at least 3, 4, 5 you can try to remember. And out of all the relational database, Oracle database is the first one developed across the globe by Oracle Corporation Company in 1979. So first database developed and released in the market is Oracle database in 1979. Today it is 2022. So 21 plus 20, 43 years happened. This database came to the market. First company, Oracle Corporation Company only developed this Oracle database. Second is Teradata. Caltech company developed that in same year 1979 only, but that is in end of that year. December around, November, December, and this Oracle introduced in January, February around. So the oldest database is Oracle, and that's why till now in many companies, 70 to 80% company, till now they are using Oracle database, and we'll also use Oracle database here. One database is using means other database also you can able to work. No need to learn, no need to do the course. One bike able to drive, other bike also you can able to drive. So the common language used will be SQL. SQL we will learn from tomorrow. So using that SQL language, we can work with any kind of database. So one database only we can focus Oracle, because 70 to 80% of the organization they are preferring and using this Oracle. And other databases also referring the code, script, features, concepts of this Oracle only. So Oracle you are expert means you are expert everywhere. Next database, Ayoka company developed in 1986 Postgres. IBM company developed in 87 DB2. Microsoft company developed SQL Server in 1989. Swedish company developed MySQL in 1995. SWAT Infosystem in 2000 SQLite. MariaDB database developed by MariaDB Corporation 2009. So these are some list given. Apart from this also so many databases are there, 100 plus databases are there. So everything no need to learn, one only focus. Any moment any database is coming, you can apply the SQL and work on that. Similarly, non-relational database for NoSQL for semi-structured data. PoachDB is the first one by Apache company in 2005. Apache company 2008 HBase. Again Apache company Cassandra 2008. So Apache is the very famous company who is developing many non-relational database for semi-structured data. MongoDB Inc. company developed MongoDB database in 2009. Orient company OrientDB 2010. Apache company again Impala 2013. So these are some list of non-relational database, NoSQL database for semi-structured data. So database will not support unstructured data. Column row will be not there. Further some other components will come to the market. We can see after few months or years whenever it will come. Okay, so for all these are the questions FAQ for interview. So tomorrow we'll ask all these questions before start the topic. You can prepare all those whatever completed, then we can start with the new topics. So we'll enter into SQL tomorrow. After that, we'll start with this practical. Any questions?
Sir, can you explain once about the normalization and denormalization? Like you said that data is the information regarding a single person, example, and will
Okay.
store everything in the like database, right? So it's
Okay.
up to the storage of that is example like till gigabyte you said, right? So when we
Okay.
have the more data, then we will
Hmm.
dump our load into the data warehouse, which has
Data warehouse.
n number of like tables and related to the more information.
Yes.
So why you said that normalization is like it's like splitting of the data into the tables, right? But in
Yes. That is,
denormalization, that is a data warehouse. But these two are same,
that is
right? If the
combined.
more, sorry.
So that is combined. Combined data is going from database. 20 tables will be combined and placed into data warehouse. That is single table. That is denormalized.
Okay. Like I thought is like if much information is there, like more data, if we require to store, we have to store in the data warehouse. Like teradata, you said like 2 terabytes, we can n number of the like we can
Yes,
store.
so you
But
can store
if
that,
we
but whenever storing, you are combining from multiple tables, right? So those
yes,
multiple tables are normalized tables. Now you are combining and storing into one table in data warehouse. So that is denormalized table.
but in the database also we are having the tables, right?
Yes, there also table, here also table. So there are 10 tables, here one table. One means denormalized, 10 means normalized.
Okay, in the one table only we are putting all the 10 tables,
Yes,
right?
yes, sir. All 10 tables data we are keeping into one place in data warehouse.
Okay, okay, okay. Got it.
Data warehouse, one place everything will be present, current plus history. In database, partly it will be split with different tables.
Okay.
Okay. Any other question?
No,
Okay,
sir.
fine then. We can close for today. Tomorrow we'll resume. Okay, after some time we'll place in the same drive. You can just go through.